Hi and welcome to the Dean Park DCC Concepts Control Panel instructional video. In this video I'll take you through the whole series of steps that I did from start to finish in order to replace the previous Pico switches with this brand new state-of-the-art control panel which controls three sides of the layout. If you've not already done so, please hit that subscribe button and the notification bell, and if you want more information on Dean Park, join the Dean Park Station closed Facebook group or join me on Instagram. Any questions regarding this, please get in touch. After waiting for a long time, I finally got my hands on the DCC Solenoid accessory decoders that I need to upgrade the point switching at the station side of the layout. So on the left hand side at the moment I've got the Pico red and yellow switches and they're powered by 15 volts AC. You can see on the right hand side of the screen I've got my storage yard digital display, if you like, with the LEDs. I'm going to upgrade the station side to match that. So I've spent a lot of time accumulating the DCC Concepts equipment, preparing the layout, and what I'm going to do in this video is I'm going to take you through how I go from the scenario at the left to end up with the new control panel similar to the one at the right hand side of the screen. Hope you enjoy. Any questions, please do ask. I'm not an expert on the wiring side of things. I'm just following the instructions in the leaflet and hopefully I'll get there. I managed it with the storage yard, so hopefully the same can be the case with the station side. One of the reasons I'm actually going to upgrade the system is to reduce the amount of wire under the baseboard. Each of the turnouts is wired back to the switchboard, and that is a lot of wire, as you could see there. And when it gets to the switchboard, it continues. Because I've got a pull-out tray, I've got to have that looped slack there, and then it goes into the black terminals and then along the lines into the actual levers. Because I'm going to use the ECOS system, the turnouts just go straight into the power bus, so there's no wire going to and from a switchboard. It's all transferred via the DCC bus, so it's going to cut down this amount of wire dramatically. It'll allow me to tidy up some of the other wires as well that go into the signals and the feeder wires from the track. So all in all, this will be transformed. So I'll take a photo of it at the start and I'll take a photo at the end, and hopefully there'll be a massive difference. Right, that's me stripped everything out now from the old DC system, and that is the spare or excess wire that I no longer require. I don't know how many meters is there, but it certainly take a long time to strip out, and I'll be recycling that obviously and getting some use out of it later on. It's now a case of focusing on installing the new wiring, which has all been braided nice and neatly, and obviously the DCC concepts boards. What I'll do is I'll install one of them and I'll show you how it all kind of is wired up. I've removed all previous switches and wiring and board from this area, and straight away there's a mass of open space. It's not cluttered with wires. What I've done is I've fitted this frame that I built. I built this in my little kind of workshop kind of shed. I've got basic tools, a drill, a vise, and methods of cutting. Now the frame is the same as was used on the storage yard control panel. In fact, I did make these up at the same time as I did the control panel in the storage yard, so they're a couple of years old. They've just finally obviously got onto the layout. A lot of people might think, oh, why are you taking so long to kind of upgrade this? Well, I was kind of waiting on the DCC concepts, basically solenoid decoders. They were out of stock for a long time, so obviously I couldn't upgrade without them. So I've now got this fitted in place. It's glued and it's screwed. It's screwed to the trusses. I've got this supporting bar across the top there, which will help rest the control panel, as I'll show you in a second, and this rail here, which has been planed, hand planed to a matching angle as the sides there. So when I get my control panel, it all just sits in there like so, and I'll screw it onto the top there, the sides and the bottom. Alright, so that is the basic makeup of the control. It's an overhang at the bottom corner or bottom edges here. That's deliberate, because if the whole thing isn't perfectly square, you're not going to notice you know, the unevenness of the frame. If you were to butt it right up against the edge and it was a bit unsquare, it would, you know, stick out like a sore thumb. That's just my years in, you know, craft and woodworking kind of bearing fruit there, just my experience. So that will get screwed on there eventually when all the circuitry is done. The first thing I'm going to do here is I'm going to install the DCC Concept solenoid decoders. These come in three different types. You've got the 4SX, which has got 4 outputs. You've got the 2SX, obviously half this size, and the one with the 8 outputs, which is the 8SX. And I'm going to use a combination of all three here. The reason I'm going to do that is you're trying to position the decoders as near as possible to the turnouts above. If you have it too far away, and you obviously wired this to the solenoid point, the resistance in the wire builds up, which is simple electronics, and it doesn't give the solenoid a powerful kick to flick the point. It still will pass the signal, but you might have a little bit of a sticky point motor that needs a bit extra kick, and you really want these as close as you can. In my storage yard, for example, I used 8 SXs because all the points were quite close together in that formation, so I got away with it. The wires were less than a metre long in every case, which is totally fine for this. When you're looking at the point being, you know, 1.5 to 2 metres away from this thing, it starts to obviously build up the resistance in the actual core of the cable. So I'll show you this one installed first. It's very simple to install. You wire the 2 outputs here that you can just see to the DCC bus, the same bus wire that your track droppers go into for powering your trains. So that goes into there, and then these 3 here on each one are the ones for the solenoids. And you've obviously got 3 wires coming from your point motor. You've got a common and you've got a left and a right, so it's easy to wire up. These things here are for frog switching and LEDs if you want to really go to town and have everything installed in there. I could have a point switch, you know, for throwing the polarity of the point, the frog, by using these three. I'm going to stick with my Pico accessory decoders because they're already fitted to the point motors as it is. But I've not ruled out using these 3 ports in the future. These are obviously for light signal switches and all this kind of stuff. You can really, as I say, go to town on it. So I'll show you this installed, and then I'll show you how I would program this unit to speak to the ECOS, which you can see on this display board here. That's the ADS 4SX solenoid decoder from DCC Concepts now installed. I've got 2 wires coming from the end here, and they go into the DCC bus. That's the same bus that powers the track, which is obviously linked to the ECOS system. Then you'll see I've got 4 sets of 3 wires coming from the connectors there. They go to the 4 turnouts. The longest wire is around about 1 meter in length. You're trying to keep the wires from the decoder to the points as short as possible, to avoid any problems, and also give a positive kick to the solenoids. It's very simple to wire up. As you can see, I've just screwed it onto the framing there. Easy to get to if I need to maintain it or reprogram it. Job done. Programming the solenoid decoder to speak to your controller is very straightforward. In this case, I'm using the ECOS with my diagrams here that I've put into the system. These are all the turnouts that I'm going to be programming for the station side of the layout. If you look at the other page, I've got my depot series, and they all start at 100, 101, 102, 103, and my stations start 0, 1, 0, 2, 0, 3. And if I did, for example, the depot side of the layout, they'd probably start at 200, 201, 202, just so I can split them up. You can number it whatever you like. So in this case, I've programmed number 1, you hear it click. Number 2. Number 3. Okay. Now, on my 4 outputs here, let's just say that was number 1, that was number 2, that was number 3. I've got number 4 to program to link up to this one. To do that is easy. Obviously, if we've got this wired into the system, you flick this little switch here towards the outer part of the board, and that means this area here is now open to programming. The other 3 are fine. I would then press on the ECOS, press 04, and that would send the signal to this area here. I would then go and lock it in place, so that's now set as 04, or whatever number you've chosen, and then when I press it, it will kick the solenoid and the turnout will move. Okay. So it really is very simple to program one of these to the ECOS. It's a simple case of wiring it all up, having a diagram, and then opening the switch here to allow each one in turn to be programmed. You've got to program one each at a time. For example, if I opened that one and programmed it at number 4, both would be number 4, which would be pointless. Okay? If you've got points facing each other, in the case of, let's just say here, where I've got 05, and it's a left hand and the right hand point facing each other, I've just used 1 port for that. You get both sets of wires coming in to there, and that means when you press 05, both turnouts will obviously move and fire at the same time, because they're facing each other. They've both got to work together, or you're going to have a derailment. I hope that's fairly clear how I've explained it. If you do have the ECOS and you're upgrading to the solenoid decoders from DCC Concept, it really is, once you get your head around it, very simple. Okay, this is where the brains, if you like, of the control panel lie, and this is where all the circuitry goes to feed into the switches, the LEDs, and in turn the DCC supply and the track. Now what I've got here is a Cobalt Alpha AEU unit, okay, and This will be connected to the switches, as in the toggle switches on the control panel. And all these little ports along the bottom here, there's 3 there, 3 there, 3 there, and 3 there, 3 sets that is. They will go to the toggle switches. And because my control panel is quite large, I'll also require some of these as well. Not all of them, I have to say. They'll be linked together by a simple cable, also known as daisy chaining, so it's in a line. So that will be able to communicate with that. Okay, and it's programmable, so when you get your system set up, which I'll show you later, the switch there will be given you know, an address, if you like, and it'll all kind of work and talk to the ECOS. So this section here is just for controlling the toggles to therefore speak to the DCC control unit. Okay, then I'll add a couple of these things. All right, and these are the Cobalt Alpha mimics. Okay, and this will be where the LEDs from the control panel will be connected, all these little things here, and that in turn will be feeding into a DCC supply, and again I'll have 2 of them, and they'll be daisy chained together by a cord. So this will control the LED lighting, and this will control the switches, the toggle switches, and it will all be linked into the DCC system. There'll be a lot of wires getting attached to this as we go through the video, and it might become a bit of a haze, but if you just remember that these units along the bottom here will be controlling the toggle switches, and they will be controlling the LEDs. Right, I'm now going to program the 2 mimic boards, okay, and those are the ones that are getting connected to the LEDs, remember, on the board. All right, they are nothing at all to do with you physically switching anything. They will automatically read which point has been thrown through the DCC system when I flick the switches on this AEU board, which I'll go into programming later. Okay, the 2 are there joined together, called daisy chained, as DCC concept like to call it, with this 4-way ribbon cable, and a black and a red cable there take it through to the DCC power bus. All right, so it's programmed into the main power bus. So obviously any signals coming from the ECOS it'll pick up on and change the LEDs. Okay, programming the mimics very straightforward. One thing you've got to do when you're watching this video is remember this one is upside down, so that's the left hand button, that's the right hand button, and you'll see when the display comes up what I mean by that. All right, I've put it upside down purely for the reason that I can have the LEDs getting wired as close to the actual panel as I can. Okay, if I had it the right way round, one would be a way up here instead of down here. That suits me more. Doesn't really matter which way you do it, just the instructions are the same. Right, so hold down the left hand button and press on, and what will happen is it says 0001, or in this case upside down. You can then scroll through the numbers depending on what you want. Okay, so let's just say you wanted 2001, etc, etc. I'm wanting this as 1, so I move along, I'm happy with that. Okay, it now tells me in the instructions that I've got to hold down this right hand button, in my case the left, until it says yes. There we go, an upside down yes. Now because I've got this board linked to this one, that is automatically programmed that as well. This is program number 1 through to 12, and that'll be obviously 13 onwards. So I don't have to program the right hand one individually because it's already been done by this daisy chaining. Alright, so that is the mimic done. I can now plug in my LEDs when I get the panel assembled and it's ready to go. Just to prove it is actually working and it's been programmed, I've plugged in a couple of spare LEDs into socket number 1 there, and using my ECOS I'm going to flick the turnout, okay, and you should be able to see the LEDs change. There we go, so now we know that that is programmed correctly. Okay, what I'm doing here is I'm fitting the toggle switches to the Alpha AEU boards, okay, and each of the toggle switches has 3 wires and they go into the corresponding left, centre and right of the AEU board. It's very simple. With the switch I've got here, it's a spring return to the center position, and if I move for example, want to set the turnout in one direction, I would flick down. The other direction, I'd flick up. Now you notice it goes back to the center. It only gives a momentary pulse, which is all the solenoid needs. If I was to have an on-off switch, for example, that stayed in either or position, it would burn out the solenoid on the Pico point motor, okay? So that just sends a momentary burst. That's all it needs for the AEU to understand that that's you firing a turnout, sends it into the ECOS and then out to the actual point motor through the DCC bus. All right, it's very straightforward if you think about it. I said these are very simple push fits. There's no soldering required here. It's a simple case of getting your 3 wires from your toggle switch and bearing the ends. All right, and then let's just, for example, say this is the black's the center, so I would just plug it into the center, push, and you'll see that that orange lever, if you like, is in the up position or in the inward position, and that means that the wire is connected. And to get the wire out, you would just pull the orange connector and just release the wire. It's very straightforward, so there's no soldering, thank goodness. I just braid the wires like that for neatness. You'll also notice that I've put some heat shrink around the exposed parts where I've soldered onto the actual toggle. This is to prevent any short circuits and wires touching stuff when it's under the board and getting bent and manipulated to fit into the actual control panel. The AEU is just going from here to one of the DCC Concepts Alpha sniffer boards, and that's just so that it can talk to the ECOS. Without that, it'll not fire any of the switches, okay, because it has to be linked to your ECOS, and that is this cable here. So I'll finish doing all the toggle switches, and then I'll move on to fitting the LEDs for the Alpha Mimics. This device here is called the Alpha Sniffer board, and it links between your ESU command station and the AEU boards, which in turn are linked to the toggles. So when I fire one of the toggle switches, it comes through the sniffer and into the ECOS to tell the ECOS then to fire that point. Okay, it's almost like a bridge between the two parts of the system. Now, it's powered from a 12 volt regulated supply, which plugs into there, which you can buy. This here is an RJ12 connector. It's like your Ethernet cable for your internet. That plugs into one end and the other end goes into your AEU board. Okay, this is 500mm long. You can buy that as a set length, but you can also request a customized length on the DCC Concepts website. Okay, now when you're setting up this sniffer, it is important to keep it as close to the ECOS as you can, with the 2 wires coming from there into the back of the ECOS being kept as short as possible. Alright, I had them at say 600mm and the system didn't work. I reduced it to 400 and it worked. Because of the length of the cable and the power of the signal coming from these devices, you have to keep the wires as short as you can. I've literally got my sniffer board just to the left of the ESU command station, hidden behind the control panel. Okay, it's a matter of 300mm in length for the wires. So that's what that socket there's for. That goes from there into the back of the ECOS. You've got your power supply and you've got your RJ12, which goes from here into the AEU boards. All right, it's very simple, and it's got an on-off switch as well. And obviously, for you to control the AEU board and the toggles, it's got to be activated. Right, you'll see this cable here. The AEU boards have got white connectors at each end, okay? Input, output, input, output, clearly labelled. Obviously not got in and go into this one because this is the first in the sequence. This is the second one in the sequence, so I've obviously got this linked, or daisy chained as they call it. This one here goes all the way to the AEU boards on my storage yard, which are AEUs number 3 and number 4. So they are then linked. So this power cable here from the sniffer will power all 4. and it will power a lot more than 4, I can tell you. All right, so that's how it works. It's like daisy chain, it's simply linked. All right, so this wire will obviously be getting neatened up and tucked away and obviously fitted into the system. So that is simple in a nutshell. All right, we've got the AEU boards linked together. They then flick, and I'm going to demonstrate this working, fingers crossed. If I've got, for example, I don't know what turnout this is, up to 12, 13, 14, 15, there's 15, I would then you see it, 15 on the display. Okay, if I went to, this would be 13, because obviously the first board takes up 1 to 12, that's 13, 14, and so onwards. You can see this, the spare capacity I've got here. Right, okay, 13, 13, and you'll probably hear the point changing. Okay, and it'll appear on the display there, and it also appear on the mimics. That's just because that's linked to the DCC bus, and it picks up any signal that's going through that. All right, so it's pretty simple. You can flick switches to your heart content to set points. So the next stage is now putting the LEDs into the mimic board, into the back of the black actual control panel covering, and starting to feed these switches through. I'm going to give you a closer look at the actual control panel. This has been designed by me and then sent for laser cutting, and the material is in black acrylic. Now you'll see the actual track diagram there, and I've started to put in some of the LEDs from DCC Concepts, and I'll show you how I do that in a moment. Along the top row here we've got the 16 turnouts. Okay, along the bottom we've got R1 to R9 and R10 to RG. Now these are for setting the signals to red around this part of the layout. Okay, so for example, signal 1 is on this line here, R1. So if I want to set that one to red, I would flick the switch and it would set it manually to red. It would override the sensors, if you like. And all the R's are displayed around about the display there. Okay, the dotted line there symbolises the tunnel. So this side is before the town scene tunnels. This part here is in the station, and this along the top, as it says, is the upper level. I've even got the level crossing earmarked as well. So we've got all the R's for setting the signals to red, overriding the sensors, and I've also got all the numbers for the turnouts. Now, as has been the case with my storage yard, the LEDs will light red or green. They're dual lit coloured LEDs, depending on which way the track or the turnouts is set. So if, for example, I wanted the train to come along here and down onto this line in the station, I'd have to set 07 and 08, so these two were green, so I knew the path was set for that locomotive to pass safely across. When it comes to fitting out the actual display, whether it's this kind of display or the one you've made yourself on a bit of ply, it doesn't really matter. The LEDs go through the hole here. Okay, so let's just say I'm going to do turnout 12. Okay, so I've got the LEDs here. Remember, these are red green ones, so they can change colour depending on which way the point is set. And these little socket here go into the mimic board, which we'll go into later. So they go through the hole. Okay, so I've got one there and I've got one there, and they've got little ribs on them, so you click them into place so they don't slide about all over the shop. Okay, they are now firmly in place and supported. Now it's going to start getting quite busy at the back here. So what I've done is I've each pair that come through, or in the case of turnouts that face each other, 3 LEDs, I've put a number on it that matches the number on the other side. This is so when you start putting these into the Mimic board, it's not an absolute minefield, it's easier to track. And also with maintenance, if something goes wrong, for example an LED from one of the turnouts happens to be faulty later on, you can easily trace it and replace. So these two here will get a little tag, and this is just Tamiya masking tape with a number on it, so I can then trace it. So I'll continue fitting out the rest of the board with the LEDs, and then we'll move on to the next stage in the operation. I'll just touch on this little gizmo here. This is a latching module, and what this is going to help me do is the three-way point. Because the three-way point is in essence 2-point motors, it requires 2 levers to, set one of the 3 ways on the turnout. Unfortunately, the DCC Concepts boards don't cater for 3-way points. So you need this little latching unit. Don't ask me in detail how it works. To connect to one of the LEDs, okay, in the Mimic. So when I switch, say for this example, the top route on the 3-way point, that is the only green light and the other 2 are at red. And then when I switch the center on the actual 3-way point, the top and the bottom are red and the center are green. And when the bottom route is set, the top 2 LEDs are red and the bottom one green. You'll see what I mean when I start fitting the LEDs, and I'll talk through it a little bit more. I was given this unit by a good friend of mine, Mike, who also helped me wire it up. So big thanks to you, Mike, at Hope Park Junction. It just wires into a 12-volt supply into this latching unit, which in turn goes to a double pole, double throw toggle switch, and it's got LEDs, 3 LEDs coming off. There's one there which is this, connected to the latch, and then the other 2 for the turnout. So when you get it all put together, you'll understand what I mean. But DCC Concept boards can't cope with that from the off. Okay, so that was a little module from Modelling Electronics, and the website is www.modelingelectronics.co.uk. I'll put the website in the description below. If you ever need to do this with a 3-way point, you'll need a latching unit so the LEDs work correctly. Right, that's the LEDs now wired into the Mimic, as you can see from this bird's nest of wiring here. It's very simple. The 2 LEDs from each turnout go into the corresponding 2 sockets on the Mimic. Okay, you'll obviously get 2 wires coming from each turnout. I would take them together and number them like I've done, so I can find out which ones I'm going to, and also makes replacing LEDs and fault finding easier later on. If you've not got a long enough cable from the LED to the Mimic, as in the case of port 12 here, that's 1, that's around to 12, use these extension plugs, extension wires. They're 150mm long, you get them in different lengths, and just this extension connector here. It's very straightforward. When you've got 2 turnouts facing each other and you're throwing them with one switch, say I've got number 5 here, and it's a pair of left-hand turnouts obviously going into each other, you can connect them with one of these. So one LED goes straight to the control panel, and then the other 2, because you've got 3 in the sequence, 2 go into there, and that one goes to the Mimic board. Right, so obviously, so when you flick the turnouts, you're not going to get conflicting routes. I'll now put this panel on. I'll screw it into position, and that'll let you see the LEDs lit up on the control panel. That's the control panel now partly screwed on. I've only put screws at the top left and the right just to get it in position just now, and then once I've fitted it all out and I'm happy with its operation, I'll apply the rest of the screws. Okay, right, it should be working now. Let's pick a turnout that we can see on the screen here. I've got 6. Okay, at the moment 6 is set for the lines to go straight on, so this middle bit is obviously red. If I now flick obviously on the ECOS just now, because I've not got the toggles, you can see the centre has now gone to green and these 2 are red. So any train coming that way would obviously have to stop and the same the other way. Okay, so I put 6 back, it goes back to the green with the red. You can see the display there as well showing that number 6 has been thrown. Let's just go to say 10 here, which is a normal turnout on its own. 10, there we go, tells me 10, green to red, red to green. And the toggle switches at the bottom will just do exactly the same job, but they'll go through the alpha AEU boards into the sniffer, into the ECOS. So the next stage for me now really is to fit out all of these 1 to 16 toggle switches. Okay, I'll give you a brief run through of how the system works now that it's fully operational. As I've said to you before, it's all linked through my ESU ECOS command station, and at the moment I've got the train driving screen there. I could have singular or multiple driving screens. And there are up to 10 trains I can control at once as a visual screen. Okay, I could have more, but then obviously I wouldn't be able to see them all, which is potentially disastrous. So let's just say I want to control the points. I'd go to the point setting there, and on the screen you can see some of the points. Let's just say I want to fire number 4, touchscreen, back again, done. Simple, okay, but that, as I said, is a bit of an issue. I'm driving a lot of trains. So I installed this board to cater for that. Now, let's just say I want to fire number 4. The LEDs change on number 4, even if I use the touchscreen. And you'll notice also the number of the turnout that I fired appears here. So watch the LEDs if you can see these clearly. I know there's a lot of reflection from the lights on the roof. It's changed the LED back to green and then red, and then it's displayed the numbers 0004 or whatever the turnout number is, okay? Now, if I wanted to control it just using this, I would just use the toggle for 4. It fires, it indicates, and it also changes on the touchscreen because it's all integrated. I want to fire it back, LED changes, the point obviously fires, and the display shows the turnout as well. So it is very simple to link from the ECOS to have this option or the touchscreen option, and that is all linked through that alpha sniffer. On this board I've obviously got a few more features than just point control. Let's look down here at the bottom. The green and the red are for the level crossing. I can override the automated system there by putting it on or off as I choose, alright? I've got lights 1, 2 and 3 here, and accessory. Lights 1 do the station, lights 2 do the other 2 sides of the layout. Lights 3 is at the moment redundant, as is the accessory toggle there as well. These are just future proofing. If I want to do some expansion and separate lighting features and accessories, I can put them in there without redesigning the whole board, okay? At the bottom here we've got R numbers. We've got R1 to 15, and these set the signals to red, and you might be able to see R10 is up here. That's the position of the signal on the line, and if I want to set it to red, I just flick the switch down and that signal will go to red regardless of the aspect that it was before. A cool feature of that is if I set that signal to red, R10, the previous one in the sequence goes to yellow, so it doesn't just stay at green. So it's quite cool. They're all linked through the Heathcote electronic boards, and one of the features is that you can set the signals to red. So I've never really utilised it before in a big way, but I've made sure with this board I can control signals on 3 sides of the layout by setting them to red, okay? It's a nice feature. You can play with it and become a signalman, okay? So R10 is currently at red, R11 the same, etc. Now there's no indication visually on the board that that is the case. I could have fitted LEDs, but I felt that the board would be too cluttered with lights and really confuse the actual point control, which is the main purpose of the board. So I didn't bother going down that route. Obviously if the switch is in a lower position, that means it's red, all right? And they're all programmed and set up to be like that. panning down, you'll see an RG here. This is red or green, and this is platform 7, okay? And it's a 2-aspect signal, and I can override it to be red or green, okay? Controlling it manually, and override the automatic system here on the 3-way point. I'm just going to focus in on this 3-way point here, which is point motors 13 and 14, okay? There is obviously 2 point motors under a Pico 3-way point. At the moment it's set to go the top route, which is platform 6, which is the HST platform, the longest at Dean Park, which is fine. And thankfully the other 2 are set at red. Now the DCC concept stuff is amazing, but it doesn't cater out of the box for a 3-way point. So you've got to add a latching relay module, and this was supplied by a good friend of mine, Mike Wellsby, who helped me through the installation. It was a big help, and his electronic knowledge is certainly way above mine. And the unit itself is from Modelling Electronics, and I'll put the website in the description below. At the moment, I say it's set to the top route. If I want to set it to the middle route, it's case of number 13. And there we go, it's set to the middle route, the bottom stayed red, and the top has gone to red. So it can only go one route, which is a relief for everybody on board the train. If we want to go to the bottom route, this is where the latch comes in, and I'll do number 14, and there we go. It sets it to the bottom. And that wouldn't have been possible without this relay, okay? And if I want to go back to the centre route, it's 14, and then the top route, it's 13. It really is simple once it's installed, but trust me, it had me scratched my head for a wee while, but thanks to Mike I managed to get it installed without any major upsets. So that's the 3-way point taken care of, and I really am glad that I managed to get that working. You can probably see the sharpness of the lines from this zoomed in angle, even down to the outline around the numbers and letters. The laser cut really does do a good job. So there you go, the ESU ECOS command station with DCC concept alpha boards to give a state-of-the-art control centre. Now, if you have any questions regarding what you've seen, please do get in touch. I hope you've managed to follow it, and again, if you've not already done so, please hit that subscribe button and notification bell. Thanks for watching, cheers just now.